A very warm welcome to all the learners. This is my new YouTube channel, and I'm thrilled to start this journey of learning with you. On this channel, we'll explore science concepts in a simple and engaging way. So, let's begin our first video where we'll be focusing on the new NCERT textbooks which have been released in the last few years. For class 8, the book was released earlier this year. That was a couple of months back. So the new NCERT science book for class 8, as you know, was released this year itself. And in this series, we'll be exploring for now the concepts from this updated edition of science book. Now, understanding and estimating that most schools will begin term 2 from, in my understanding, chapter number 7. So we'll start our journey from this chapter, keeping in mind that I'll cover other chapters in the upcoming videos slowly and steadily. So let's begin with chapter number 7. Let's dive directly into it and make this chapter easy to understand and grasp. Now, the chapter number 7 is the particulate nature of matter. So this chapter primarily focuses on what exactly is matter and what is the nature of matter. So matter, as we know, is anything that occupies space and has its own weight. That is, it has some mass and it occupies a space. So matter can be anything. It can be solid, liquid or gas, as we know from a basic understanding. That means a textbook lying in front of us is a matter. A glass full of water is matter. The room that we are sitting in has air around us, therefore that air is also a part of matter. It is also a state of matter, in fact. Now, so when I talk about the particulate nature of matter, it simply means that every state of matter has a particle-like behavior. That means they are composed of particles. So every state of matter is made up of particles, which we will understand further in this chapter as we gradually move ahead. Now, we have seen matter around us everywhere. We are made up of matter. Everything in our surrounding is made up of matter. Now, what exactly is matter made up of? The question simply is to understand what further lies, what further subdivisions are there when I talk about matter. Is there anything which is smaller than matter, or is matter in itself the entity which cannot be further broken down? So to answer this question, we can simply say that matter is composed of further finer particles, which if I keep on breaking down one form of matter, eventually I'll reach to a stage from where it cannot be further broken down into smaller particles. So in simple terms, what I mean is, agar if I have a chalk stick in front of me and if I keep on breaking it down, एक stage आएगी जिसके beyond I will not be able to break or make that chalk के particles even smaller. Now, these chalk के particles, which eventually are formed after breaking down the stick of chalk, are called as a constituent particles, as it is mentioned here in the book. Every single matter is made up of constituent particles, and these constituent particles eventually come together to give rise to that state of matter. So for example, if I talk about solids, in solids these constituent particles are very close to each other, and these constituent particles eventually help in forming the substance. So for example, if I have a state of matter here, for example, this is solid. You can see that every single state of matter, every single constituent particles can be seen very, very easily in this representation, in the simulation. So it is for the case of neon gas. You can change it for argon, you can change it for oxygen, we can change it for water as well. So we can very, very easily and clearly see that when the state is solid, the constituent particles are very close to each other. So in simple terms, we can very easily understand that every state of matter is made up of some particles, and since these states of matter constitute some particles, these particles are known as the constituent particles. If I turn to the liquid state, you can again see the liquid, any liquid, be it water, be it oxygen, be it anything, is made up of, again, the constituent particles. The difference between these constituent particles of solid, liquid and gas can be discussed a little bit later, but primarily we'll right now focus on these constituent particles. Now, coming on to gas, again we can see the gaseous molecules are made up of their own constituent particles. Now, what exactly are these constituent particles? So when I talk about the constituent particles, again it primarily means सबसे छोटा particle with which actually forms a building block of that entire state of matter. So when I talk about the building block for any living organism, the building block of any living organism is a cell. On the other hand, the building block of any matter is an atom. Now, so this atom can be also considered as a constituent particle. So for any matter, the smallest entity which cannot be further broken down is an atom. So if I keep on hammering a piece of chalk, the last stage beyond which it cannot be further broken down would be the stage when I actually come to a state where I break it down into the singular atomic pieces. So the smallest entity which actually ends up forming the building block for any material is an atom. Alright, so when these constituent particles are combined together, they eventually end up forming the state of matter itself, which can be, in this case, a piece of chalk. Just like chalk, the grains of sand and clay are not the smallest unit of a bigger rock. In fact, they can further be broken down, and a single piece of chalk, clay or sand consists of millions and millions of such small constituent particles. So even if एक छोटा सा chalk का piece is lying in front of you, that piece of chalk consists and constitutes of millions and millions of these constituent particles. Now, let's perform another experiment to understand how small these constituent particles are and how many of these constituent particles would be present in a small sample of any state of matter. So in this case, we will take a small glass and we'll take a glass of water, and then we'll just add a few tablespoons of sugar into the glass as shown in the figure here. Now, at first, according to this activity, we will not stir the contents of the glass. We will just let the sugar settle down, and using the spoon, we'll just take the contents from the top of the glass and try to taste the contents of the glass. Do you feel that the water tastes sweet? The answer would be no. This is because the sugar has not yet dissolved in the contents of the water. That means water के अंदर अब तक sugar dissolve नहीं हुई है. So therefore अब तक उसमें sugar का taste नहीं आ रहा है. But when I start to stir the contents, that is when I start to stir the sugar present inside this glass tumbler, it will get dissolved, and after some time, if I take a sip from this glass, it will start to taste sweet. The reason behind this is that when I talk about the state of matter, that is liquid, I can very easily see in this representation here that in solids, the matter, the constituent particles are close to each other. When I move to liquids, they are a little spread apart. They are a little far away from each other, whereas in case of gases, they are the farthest. So to understand this more, let us try to just interpret the data and see what will happen when I mix a tablespoon of sugar in a glass tumbler. So assuming that, yes. So this is, suppose, the glass tumbler in which there's some water. So I am adding the water molecules like this. Since liquid molecules are somewhat loosely packed, so therefore there would be interparticle space in between them. there would be spacing in between the constituent particles of the matter. So particles are loosely packed and there's space between them. I add some sugar to it. I'm representing some sugar crystals by this green color. So on adding sugar, what I find is, first, since it did not dissolve, I did not stir the contents, the sugar was not dissolved. When I took a spoonful of this water from the top, I did not taste any sweetness from it because the sugar was not yet dissolved. But after stirring the contents up, these sugar particles further disintegrated into smaller constituent particles. So smaller sugar fragments were formed after the dissolution or after stirring the crystal of the sugar. After stirring sugar, simply the contents of the mixture were stirred, so it eventually meant that the sugar got disintegrated into smaller and smaller fragments. Now, this further got disintegrated into smaller pieces till a stage where all the sugar got dissolved. Now, where does the sugar go? Does it vanish? Does the volume of the solution increase? Where does exactly the sugar go? So you will find that when I add sugar to water, the volume of the solution does not increase. So agar pani ki volume pehle was 15 ml, it still would remain 15 ml even after adding 1 or 2 tablespoonful of sugar, because sugar ke particles get dissolved in between the spaces of the liquid constituent particles. That is, the liquid के जो molecules हैं, जो liquid के particles हैं, sugar उनके बीच में जाकर के dissolve हो जाती है, and this eventually makes the liquid not experience any rise in its volume. So the volume remains the same. Why? Because sugar is getting accommodated in the space, in the interparticle space of the particles of this liquid. Now this space can be occupied only and only, that means only that much sugar can be dissolved in the given amount of water when all the space is occupied, when all the space between the liquid molecules gets occupied, the solution becomes saturated. At a particular temperature and at a particular pressure, when no more sugar can be accommodated, when no more sugar can be dissolved in a given sample of solute, in a given sample of solvent, the solution is said to be saturated. So in this case, the solution will get saturated when all the sugar particles will end up occupying the space in between the water molecules, which would result in no more space being left for any new sugar particle to get dissolved. And now the solution is said to be saturated. And this means that no more water level will increase, because the sugar is getting dissolved in between the particles of water, in between the molecules of water, which results in no increase in volume. So when after it gets dissolved, if I take a spoonful of it and taste it, it will taste sweet because the sugar has mixed everywhere in the contents of the beaker, in the contents of this vessel. Now coming back to this topic in the book. Yes. So this is what exactly the activity says. First, the glass tumbler has been filled. We add 2 tablespoons of sugar. We do not stir it. When we taste it, does it taste sweet? No. Now stir the water till the sugar completely gets dissolved. Now taste it. Now taste the contents from this vessel. Does it taste sweet? Yes, it does. Why? Because all the contents, the entire content of this glass vessel has sugar dissolved in it. So अब sugar is not any more sugar. It has broken down into its smaller particles, it has disintegrated into its constituent particles, and it has dissolved into the spaces found in between the particles of this liquid. So each grain of sugar is made up of millions and millions of such constituent particles, and therefore sugar cannot be seen any longer. It cannot be seen, but its presence can be felt by the sensation of taste.